Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we want to talk about an important concept in physics. Constant acceleration. So very often what happens is that an object will be under constant acceleration. Later on we'll learn a classic example is we're on the Earth. And on the Earth, we live on the Earth, and there's a particular acceleration of gravity. When I drop a pin, if I drop anything, we are living in a constant acceleration world. More on that later. But there's lots of ways that this is going to apply to the way our world works. But what does that mean, constant acceleration? If you were to plot an A versus T graph, if it's a constant, it's a flat line. Like let's say this is at 5 meters per second squared. Now remember, what does that mean, acceleration? It means that something's getting faster by 5 meters per second every second. So at time 0, it's going 0 meters per second. At time 1 second, it's going 5. At time, so this is velocity, and this is time. At time 2, it's going 10. At time 3, it's going 15. It's getting faster and faster and faster and faster and faster. You can also have a constant acceleration that's in a negative direction, right? It's slowing down. That's the deceleration we learned about earlier. And so when you live in a constant acceleration world, like we do here on Earth, what you've got are lots of problems that are related to constant acceleration. It turns out there's a series of equations that you need to know to solve these problems. They're awesome. You'll get to know these equations. You want to jot these down. You're going to use these over and over and over again in this class. So let's talk about the first equation. I'm going to do this in the x direction. It actually applies to all the directions. And let me just go ahead and write out the first equation, and we'll talk about it, what it means, okay? Now this is a very fancy equation with lots of letters and numbers. X, all right, so let's make sure we define what each term is so we understand what this equation is. So x has to do with distance, right? Distance in the x direction. Now what is the little f and the I? So the x, so the reason I'm writing a subscript x is this is in the x direction. We'll talk about later what it means it's in the y direction or whatever. If I say f, the little f, the baby f, is final, and the little I is initial. Oftentimes you'll have an initial condition where it's at rest, and so the zero might be 0, right? V, of course, stands for velocity. So this is the initial velocity in the x direction. T is time, of course. And A, of course, is acceleration. Now notice that time is here and here. Also notice that we've got arrows here, here, and here, or vectors. We've got 4 vectors. You can have a vector in the x direction. So these have, a magnitude and also direction. Velocity can have magnitude and direction, and acceleration can have magnitude and direction, but time can't. So this is the first equation, and really the most important equation. And the reality is all the equations that we're going to look at derive from this master equation. But I could have just as well written in the y direction as well, and I could have, then I can solve problems. So this is sort of the key master equation. Now what's the second equation? Again, super important that you write down these equations. It's this, Vx final, right, equals Vx initial plus AT. Now these are vectors right here. Time, by the way, can't be a vector because there's no direction to time. Time always moves forward in one direction. So time is not a vector. So that's the second equation. And then the third equation, again, I think you understand what the x's are. And again, I could have just as well written this in the y direction. And the third equation is this. And you've got Vx final squared, that's important, Vx initial squared equals Vx initial squared plus 2 acceleration. Now delta x is the change in x. If you look up here, you start with a final and you go to an initial, or you subtract the 2, you find the difference, and then you solve the problem. So these are the big 3 equations that you're going to be using when you're solving problems in this class for this. Houston, we don't have a problem.